Hi everyone, and welcome to Revit. My name is Ari, and I'm an AEC Technical Specialist with Digital Drafting Systems. Today, we're going to be creating parametric display cases. These are very special. As you expand or contract any length or width on the case or height, the different components associated with it will move together. So I'll show you how to make the case and its separate shelf and peg, and I'll show you why I made them separately. Let's make a new family. And we can use the generic model template. It's a very good template to use, but we're going to be using the furniture one because it's a bit more specific to our needs. As you can see when we first started, we're going to have these reference planes that are very useful. These are not to be confused with reference lines. The planes themselves actually go through all the way into infinity. So if I click on this one and I go to my front view, you'll see that it's still highlighted, so the same reference plane is right here. This reference plane, of course, happens to be a bit different. It apparently is tied in with the reference level, so it's not a reference, and it's automatically locked. Let's go back and let's make some reference planes. We're going to make our reference planes first so that our extrusions have a place to go. We're going to offset by 1 foot. We're going to be making a square display case. So everything's going to be centered around the center of our 2 major reference planes. You can see here that this reference is the left-right one, and this one is the front-back one. Every other reference is actually a weak reference, so those are going to be made from major ones. So it's very important to do that. Let's start making dimensions. We want this to be centered, so we're going to start from the major reference plane onto one of the minor ones. And let's change our scale so that our text is a little bit smaller. There we go. And now we can take this and edit the witness lines, click on the next one, and equalize both so they're locked and loaded. Let's do the same thing from major to minor. And let's click on it once more, edit witness lines, and equalize. Excellent. Now we're going to place some overall dimensions above our equalized dimensions. Everything will now be centered along the 2 reference planes, and these length and width dimensions are going to be labeled by the Create Parameter button right here. Let's make this one called Plate Length. This will be the overall length of our entire case. And this will be Plate Width. All right, these are ready. Let's go to our front view and let's see what we can get here to get started. So we're going to like some pegs and then our first plate. These support pegs are going to be about 6 inches tall. So let's change our offset to 6 inches, pick lines once again, and we've got that ready. Now let's set our offset to 1 inch, and now we have our plate thickness right here. We can get these dimensions ready, so let's put them in. We'll have a peg height here. Now, because the peg height and the bottom of the bottom plate are associated with each other, I'm going to name it as such. Peg height comes first because we're always working from the bottom up, from major to minor, and then bottom of bottom plate. That's a good way to name it. Very simple, conventional way. All right, we have that ready. Let's make one more dimension, and this is going to be our plate thickness. Bottom plate thickness. If both plates, top and bottom, will be the same size, then you don't have to specify, and you can use both parameters for the same components, or the same parameter for both components, excuse me. But in this case, we're going to have different thicknesses for both. All right, we have these ready. We can make our extrusion. We may as well do it now. So this is going to be our plate. We're not going to be making the pegs here. We're going to make the pegs in a separate kind of family. So we're going to use pick lines. We're going to make sure that our lines lock automatically to wherever we pick. And because we're picking these reference planes, they're going to lock to them. The depth is going to be set to 1 inch, but for now that's going to automatically change. Once we set our extrusion start to 6 and our extrusion end to 7 inches, now our depth is 1 inch. Now we can pick these reference planes, and we can use the trim tool to trim our lines. And you can see that as I place the lines, they all automatically locked to the reference planes. And you can see these lock symbols right here. All right, before we finish this, let's make a start-end radius arc. We could wait until we have some guidelines, but here I'm just using the dimension guide right there to go about 1 inch that way. And then to go about 1 inch this way, we would basically need to go here and then directly up. It's a bit hard to do. So in this case, we're going to wait until we have reference lines, and for now, we're going to let that extrusion go. Let's look at it in the front view. Excellent. Our extrusion is ready. Now we can lock the extrusion to these reference lines. So we'll lock it to this one and this one with the align tool. That way, as the reference lines move, the extrusion will move with it. So I can change my thickness if I wanted to right now. For example, the bottom plate thickness can become 3 inches, and there we go. The actual bottom plate has moved. Let's go to shaded so we can see it better. There we go. And let's go and make it 1 inch once again. Excellent. All right. Now that we have this ready, let's make our peg, because our peg is technically one of the first components. First, we're going to be saving what we're doing. So let's save this under our recording. We're going to call this display case underscore recording. There we go. All right, let's make our peg. We're going to be making a new family for the peg. Soon you'll see why I'm doing this. We'll also use the same furniture template that we used for the display case. And let's make our extrusion first. We can make a circular peg. It's going to be pretty small. I'd say a good 1 inch radius, so a 2 inch diameter. And if we wanted to, we could actually click on this and make this a parameter as well. We can actually change the size of the peg whenever we want to. So the peg size has now been allocated. It is now set in stone. Excellent. We can change our scale so that's a bit smaller. And the peg is not quite ready. We want it to start at 0 and end at 6 inches. We can click apply and then OK. All right. So the reference level dimensions are ready. Let's look at our front parameters and dimensions, and let's make the height of the peg here. Let's do pick lines. Our offset will be 6 inches, and let's offset up to there. Now we'll make a dimension. Make sure that you don't click on the actual reference level, but instead you use the tab key while mousing over it to click on the reference plane itself. So we click on both reference planes, click right here, change our scale, and let's set this one to be simply peg height. So we have peg size and peg height. The peg is now perfectly parametered and dimensioned and ready to go. So when we're ready, which we are, we will load and close in a project. Let's save our changes. We're going to put it in our subfamilies folder, and we'll call it DC underscore R underscore peg. Display case underscore recording underscore peg, just to save some time. All right, there's the peg in our crosshairs, and we can place it right there in the center of our 2 reference planes for now. We are not going to put it there permanently. We want to have 4 pegs near each corner, roughly 3 inches from each corner to be exact. So now that we have our peg here, let's make some more guidelines. And these guidelines are also going to help us make that arc that I was talking about. We're going to go back to pick lines. Our offset this time will be 1 inch because we're going to set up guidelines for our vertical supports and for our peg. So I'm going 1 inch from the outside to the inside. There we go. And one more time, so that way we get that 3rd inch from this 3rd line. Excellent. All our lines are secure. Now we can use the align tool to move this peg in position. We want it to align to this area, and you can see that the peg now has grips and this vertical line right here. You'll see that as I try to align it to this horizontal line, a horizontal line appears as well, and that means that had the peg been made in this family, we would not see those lines. Because we made it as a separate family, we have more grips and more control over the peg itself. It's very useful, and we can ensure that we've locked it based on these 2 locks. Let's take our peg that we've put perfectly in place. We're going to mirror it, and we're going to use the Control key to select both of them and mirror once again. Now, you'll notice that this peg is locked, but these 3 are not. So let's lock them quickly. I'm going to use the Align tool right here and there. The Align tool goes there and there. And there we go. All 4 pegs are now locked to their respective reference planes. Excellent. Let's save our progress. Our pegs are nearly complete and they are in place. Before we do anything else, we want to set these dimensions to be pretty much static. We don't want them to change, so therefore they don't need to be parameters. They're just going to be regular dimensions. So we'll start with the 1 inch dimension going from outwards to inwards, and so on and so forth. Now we have our 1, 2, and 3 inch dimensions. Let's do it 3 more times. There we go. About there. And about here. Third time is the charm, of course. Right here and there. All right, and one more time. These dimensions are going to be very useful. If these dimensions are not placed here, then as we change the size of the plate, the pegs will not move. They will merely stay where their reference planes are. But now that we've associated the reference planes to the other reference planes, namely this one, this one, this one, and this one, now we're going to see how these dimensions work. So let's do some testing. So here is our little table that we've made, the beginnings of our display case. We're going to go into realistic mode. And let's go and flex. We're going to change the dimensions and see what happens. We're going to change our length to 3 feet, and look at that. The pegs moved along with the actual plate itself. Very nice. So that is exactly what we want to see. And just in case we're going to test our width, we'll set it to 4 feet, just another different number. There we go. Our legs are moving correctly. They have been locked, and those dimensions that we made are quite useful. Excellent. We're now ready to move on. But before we do, we want to do some further locking. Right now it's not important, but we do want to lock all of our components in the vertical section. This is going to help us when we change the height of the display case, or if you wanted to change the height of the peg itself. All right, so let's use the Align tool. Make sure we highlight that reference plane and not the level. We're going to lock this peg and this one. We're also going to lock this one and this one. Now we have to go to our back view in order to truly lock it properly. Let's get rid of our right view, our view 1, put this in this order. That's a little easier. And let's activate our back view. Set it to shaded as well. And let's do the same thing to these back pegs. We're locking it to the reference planes, not to other objects. It's very important that you use the reference planes as our guides and you don't link them to other objects. That way, if you want to change a constraint, it doesn't have to change the other object. Each constraint is kind of independent from the others. All right, looks like we have everything ready. We're going from the bottom up. Everything from the bottom up looks good. Now we're ready for our vertical supports. Let's make some vertical supports. All we need to do is make our extrusion because I believe that we are ready to do so. Lock is enabled. We're going to have the extrusion start at 7 inches and end at 2 foot 11 because the top plate is only an inch thick and the entire display case by default will be 3 feet tall. I believe that we're ready to go. We can now click on not the actual model lines but the reference planes. So we'll click on each reference plane that is relevant to our supports. And there we go. Let's use our trim tool. I'm going to trim these out nice and neatly. There we go. Good. And now that we're nearly ready, and now that we have those reference guides right here and here, we can now make that arc very easily. Let's make a 1-inch radius arc. Excellent. And now what we can do is we can click on this little symbol here to activate the dimension. And we click on it once more. The dimension is highlighted, and now we can make a new parameter. We're going to call this one corner radius. This allows the corner to remain fixed. Before we move on, let's make sure that we trim correctly. So we will trim this and that, and this and this. It's a bit hard to see because of the text, but you can always move that. All right, that is ready to go. Everything here is locked and loaded. Let's click on the check mark. And now we can copy this around. Before we do, let's modify our bottom plate to also have a nice rounded curve. So we'll make that one rather quickly, just like so. We can also apply that corner radius to this one. We can apply the same parameter to different components. And let's make sure that we trim properly. All right, we've got one corner. Let's use the tab key to select that. We're going to mirror it over here. Now, sadly, when you mirror it and you're within the same component, you are not going to keep that corner radius, but that's okay. We're going to now mirror these two one more time using the control key. There we go. Let's do some trimming first while we can still see it pretty visibly. And then we're going to add our corner radiuses to all 4. So let's make sure that we click on Activate Dimension and Corner Radius. That's number 2. There we go. Number 3. And number 4. Excellent. All 4 are ready to go. Let's click on our checkbox. Now we're good to go. Let's take our vertical support and we're going to mirror it. Now this one, because it's its own component, if we mirror another component, let's edit the extrusion to see, the corner radius stays, so we are good to go. And now we know that every other mirror of a separate component will keep any properties involved, or at least most properties, of course. When it comes to locking to different reference planes, it will not keep that because you're making a new component. Hence, Revit assumes that you want to make a new link to a different reference, if that's what you want to do at all. Good. Now that we have our places in our vertical supports in position, let's go to our front view. And here we can now take our supports and we need to lock them to certain reference planes. Before we do, let's make a few more reference planes. Let's right click on this one, create similar, and we're going to offset this one 2 feet 4 inches to account for the 7 inches below. And that way we go right to the top of this vertical support. We're going to change that now to 1 inch, and now we have the thickness of our top plate. And we can move our top plate into position as well. Before we do, let's make sure that we work from the ground up. We want to lock our vertical supports to these reference planes. So let's lock this one. We're in our front view, so let's keep that in mind. We are only locking the front 2 vertical supports right now to the top and the bottom. Good. Now let's go into our back view. Let's do the same thing. Let's change our scale in the back view. I just noticed how large the text is. There we go. And let's do this one. And now we know that all 4 supports are linked to the top and bottom. That way, when we change our display case height, it will change with it. We're going to make that display case height pretty soon. First, let's go back to our front view. And we need to get that top plate up there. If I was to copy this or move the constrain function and move it up here, the only issue is that you would actually lose a lot of information about the extrusion start and end. It would actually default to what it was and not really keep the proper one. So the best way to do this is we're going to copy this to the right. We're going to copy it about 3 feet to the right. That way we can memorize what number we just copied it to. And from here, now we can use the align tools. So we can align from top to top and from bottom to bottom. I forgot to lock the top one, so let's do that now. There we go. So now top and bottom are locked. Now we can move this extrusion 3 feet to the right. There we go. And that is perfect. Now that we have that ready, let's make more dimensions. We can make the thickness for the top right here. There we go. Oh, let's make sure that we select that properly. Excellent. And so this will be top plate thickness. All right, and now the overall height. The overall height of the entire display case from the bottom to the top. Right now it's about 3 feet. So let's call this one case height. Excellent. All right, we have our case height ready. We have all of these parameters ready. All of our parameters here are nice and set. Let's do some testing. There we are. Our display case is shaping up. Let's go to our family types and let's change the length first. Let's see what happens. Excellent. Everything has moved. The display case can now be any length that I want it to. Let's try width at 4 feet. There we go. Everything is moving accordingly. We'll undo twice, and now let's try the height. Case height, we'll set it to 4 feet as well. There we go. Our display case just got bigger, and everything moved with it. There we go. Our display case is working very well so far. Now, we're just missing the glass shelf and materials. So let's make the glass shelf. The glass shelf, we want it to lock in just like these pegs. So the glass shelf is also going to be made in a separate family. So let's do that right now. Go to New, Family. Let's use that furniture template. It's quite nice. All right, let's make our glass shelf. But first, of course, let's make the reference planes for it. So pick lines, offset of 1 foot. This is arbitrary. You can offset it to anything you'd like. I just want mine to be pretty even along the center, so I'm saving a little bit of time. We're going to equalize it just like we did with the display case itself. Edit witness lines, equalized. Once more here, from major to minor. Edit witness lines from major to minor and equalize. Now let's make our overall length for the shelf and the overall width. Let's set those parameters. And shelf width. Excellent. Those are all ready. Now let's go to our front view for this glass shelf. We can get rid of this view and this view. There we go. Put this one here, stay organized. And let's go to our front view. Our shelf is probably going to be about 1'3" away from the base. So let's offset a good 1'3". And this is the center of the shelf. So technically, this 1'3" is a little arbitrary because we actually want the top and the bottom of the shelf to have reference points, not necessarily the center yet. We'll make the center pretty soon. So let's do this one more time. We're going to change our offset to 1/8 inch because we want our glass shelf to be 1/4 inch in total. Let's zoom in so we can really see what direction we're offsetting to. And there we go. Perfect. Now we are ready to go. Let's make our extrusion. We're going to be picking lines. Once again, lock is fine. We start from 1 foot 2 space 7/8 inches. Enter. And we end at 1'3" space 1/8 inches. Enter. Excellent. Our depth is 1/4 inch. Perfect. We snap to our lines. Everything is locked and loaded. Let's trim it out. And press OK. Good. Our glass shelf is initially created. We go to our front view, and there it is. Let's make sure that it is locked to these reference planes. Excellent. Now, actually, what we might want to do is, because we want the glass shelf to move in the other drawing, we're going to undo twice. I take it back. Do not lock your glass shelf to these reference planes yet. You can do some testing later, but I think it will interfere with the actual glass shelf in the main project. I'll show you what I mean right now. Load into project and close. I believe that we're ready to go. If we want to, we can actually, before we do go, set one last little height dimension right to here. And this will be the glass shelf height. Now, actually, this isn't quite necessary to make here. So in this case, we'll make it anyway, just in case. Shelf height, because we're going to be controlling this in the main drawing very soon. Okay. So let's load and close into project. Yes, we're under subfamilies, DC_R_shelf. Excellent. Let's put our shelf off to the side for now because we want to align it and lock it to our major reference planes. There we go. And there we go. Notice that those lines are appearing on the shelf because the shelf is now one component with grips. This component, for example, does not have the same center point or grips, regardless of its shape. So, very interesting to note that you might want to make subfamilies instead of making all of your components into one family. All right, our shelf is in position. Of course, it's a bit too big. As you can see in 3D, it's clipping out. So, let's change that. And how we do so is we use a very special formula. We want the shelf to maintain itself and change its size based on the actual length of the plates. As the plates get larger and smaller, we want the shelf to also get larger and smaller. So what we're going to do is we're going to click on our shelf, and we are going to, actually before we do that, we're going to make the constraints or the parameters for the shelf. Let's make a new parameter. We're going to call it shelf length control. And this one will be shelf width control. And these are going to be modified by the plate length. So that means that we want the shelf to always be 2 inches smaller than the plate. So plate length minus 2 inches. And for the width, of course, it's plate width minus 2 inches. We click OK. And now we have to associate those parameters to the shelf. So now we click on our shelf. We go to Edit Type. We can see all those parameters that we made in the actual family itself. And now we're going to associate them. So the shelf length is going to be associated with the shelf length control. You can see that the dimensions already changed to be minus 2 inches. Shelf width, same thing, shelf width control. And there we go. And there's our shelf, perfectly fitting inside of our little vertical supports. So very, very simple, but very useful formula. All right, And now we can test and see if our shelf is actually going to flex. Let's see what happens. Let's change our plate length to 3 feet. There it is. The shelf has moved with the display case. And we check the width very quickly. Plate width to 4 feet. And notice that the dimensions are changing here as well. 2 foot 10, 3 foot 10. They're always going to be 2 inches smaller than the plate length. Incredible. There we are. We have our glass shelf. It is working as intended. All right, now that our glass shelf is in place, let's go to our front view. Now our glass shelf is going to be duplicated, and I'm going to show you how we can make multiple glass shelves. First, we're going to be making the reference plane for it, so we right-click, create similar. The glass shelf is 1 foot 3 inches to its center from the base. There we go. And now we're going to be making an array. So we click on our reference plane, and using Control, we click on the glass shelf itself. And now we're going to be making a linear array. So we make sure that all of our settings are correct. Linear, group and associate, number 2 is perfect. We move to the second, and constraint is fine. Because constraint usually affects whether you can go on the z-axis, but in this case it doesn't. We want our glass shelf to be about a foot away from the other one, and there we go. Now our second one is ready. Here it's asking me how many shelves I'd like to place once again, so I click Enter to confirm 2, and there we go. And notice that when I deselect any part of the array, that number 2 is gone. If I click it again, there's the 2. Don't click on the number, but click on the actual dimension of the number, and you'll notice that a lot of options have appeared up here. This append to end and this label. This label is great because now we can add a whole new parameter. This one's going to be called number of shelves. This is going to allow us to have multiple shelves as the case gets taller or smaller. So number of shelves is in place. Now that is disappeared, but we're going to be making another parameter, and that's going to be called shelf spacing. It's going to be in the same position in between both of those reference lines, right around here. And let's make a new parameter, shelf spacing. All right, and with that, I believe that we have every single component ready to go. Let's save what we've done, and let's go into our family types, and let's do the last bit. This is the most complicated formula of this entire family. Now we want our shelves to expand themselves while maintaining the case height and never going past the top plate. So we start with the parentheses, and our equation is as follows. The case height divided by shelf spacing, close parentheses, space minus space 1. That means that you will never have it go above the top plate, and our case height and shelf spacing are related to each other. Let's click OK, and let's test it. All right, we're now going to be making our case height a bit bigger. Let's go to 4 feet, and there we are. Look at that. It's already made an extra shelf, but it did not make the extra shelf above this. Had we not said -1, you would see an extra shelf above our top plate. Let's see, how tall can we go? Very tall. Excellent. It's continuously making shelves at an even spacing. Excellent. All right, let's undo that. Back to our default. And it looks like our display case is really working great. Everything seems to be working well. Our width and our length can be modified. Our heights can be modified. Excellent. Now, let's set some materials so that this display case isn't so drab. We are going to start with the peg material and the shelf material, because these materials should be made within their actual families. So we're going to edit the peg family, and we're going to click on the peg itself, and here we're going to click on the associate family parameter next to material, right here. We'll make a new one. It's going to be called metal peg. Excellent. Now our parameter is ready. The peg is associated to it. Let's go into family types, and let's actually give it a material. Let's go and search in our library right down here. Under metal, we can choose any kind of metal we'd like. In this case, we can choose a stainless steel polished one. There we go. And let's click OK. And now we have that material associated to the peg. Now that that's ready, we can load the project and close. All right. Let's save this. We're going to replace the existing file, and it's very important to overwrite the existing version and its parameter values all at the same time. Excellent. All right, the peg is ready. You can see that the material has slightly changed. Let's make the material for the glass shelf now. Edit the group, because the glass shelf is part of an array group. Now we can click on it and edit the family. We click on the shelf here. We're going to go to do the same process. This one is going to be called glass shelf. There we go. Let's go and give this a material now. Under glass, let's choose a nice frosted glass. That's a good one. Frosted glass will look pretty nice. Let's see what this looks like in 3D. All right, it looks to be a little different than I'm used to, but that should be fine. Load in a project and close, yes, yes, and overwrite everything, including the parameter values. And now when we click on finish, there we go. That looks a bit more translucent. Excellent. That frosted glass is good so far. And the actual render of this display case will show the actual materials in their true forms. Right now, this is just a preview. And our last material is going to be our wooden frame. I'm using Control to highlight all of the different parts of the wooden frame. We're going to be making this material within the actual family right here, of course. So, wooden frame. And let's set this material to one of my favorite materials. There's many different kinds of wood, but one particular wood that I rather like is mahogany. Let's make it mahogany. All right, and there you have it, ladies and gents. Our display case has materials. Everything is a parameter, so you can control everything under family types. When this family is loaded into projects, all you need to do is go into Edit Type. I'll show you right here with the peg. You go into Edit Type, and all of those different parameters that we made up here are going to be found here. This family was made externally, so we can see its parameters within this one. It's quite interesting how that works. Everything is seen within everything else. And there you have it. This display case now is very pretty and parametrically ready to rumble. We hope you enjoyed this tutorial. To see more videos about Revit, please visit our website at ddscad.com. We hope you have a great day.